Hi, students. In looking at the work that you've been doing for the last couple weeks, I've seen some general issues that I think we should talk about, and I think that you need some reviewing. So I want us to talk for a few minutes about integers. Okay, so integers are the positive and the negative numbers on the number line. We're not talking about decimals, we're not talking about fractions. This is what we're talking about, okay? The number line to the right goes to positive infinity. To the left, the number line goes to negative infinity. And this side, we will go to negative infinity. So when we add and subtract along the number line, I've told you in class that addition operates the same way as the plus sign on a number. So if we have plus 2, it's the same as adding 2. Likewise, if we have negative 2, it's the same way as saying plus a negative 2. Okay, and I can put parentheses there. But those two things would have the same effect when we look at operations in terms of evaluating expressions or solving equations. Now, let's change our color for a minute. Expressions. Terms. Expressions do not have equal signs. Equations have equal signs. Inequalities have an inequality sign. Within all of those, terms are separated by what? What am I going to write? By addition and subtraction. Please memorize that. Super important. Okay, let's talk about adding integers. Okay, adding integers. So we can add positive integers like 1 plus 1. We can add negative integers, negative 1 plus a negative 1. Now sometimes you'll see it written like this, negative 1 plus negative 1. When you see that, I want you to think of this. Think of the number line. Here's our 0. 1, 2, 3. We'll go on the negative side. Negative 1, negative 2, negative 3. Okay. If we have 1, so if we're starting out with 1, like we have here, this is where we are. If we have negative 1, we're here. So here's our negative 1. If we want to add a negative 1, that is the same as subtracting 1. Whenever we are subtracting or adding a negative, we need to go left. So negative 1 plus a negative 1 moves us down to negative 2. So negative 1 plus negative 1 is negative 2. What about, let's get another color. And let's make another number line. What about negative 2 plus a negative 3? Let's make 0 over here. And here's our 1. We have negative 1, negative 2, negative 3, negative 4, -5. Let's squeeze in -6. So we start out at -2, which is right here. Now we're going to add -3. Well, subtracting or taking the negative something is always going to the left. How many units to the left? 3 units. 1, 2, 3. Which means that -2 plus -3 is -5. What if I said, what is 2 plus 3? Well, you would say 5. Sounds easy, right? Well, what's that look like on the number line? Let's put 0 down here. 1, 2, 3, 4, 5. If I start out with 2 and I add 1, 2, 3 more, I end up at +5. Let's think about that and let's get another color. Here we have an invisible positive and an invisible positive, and they made a +5 when we added them together. Here we have a negative and a negative, and when we added them together, they equaled a -5. When we added the -1 to the -1, it equaled a -2. So the rule that we can come out with when we add integers is, when adding integers, if they have the same sign, then you simply add and keep the sign. Okay, so now we have a rule for adding integers that have the same sign. Now let's look at some integers that have a different sign. Let's look at -4 plus +2. We'll start with the number line. So let's see, put our 0 in the middle. 1, 2, 3, 4. -1, -2, -3, -4. So we said that when you add or go positive, you always go to the right. When you subtract or you have a negative, you go to the left. So the -4 starts out right here. But we're adding 2. That means we go to the right. 1, 2. Where are we? We're at -2. So -4 plus 2 equals -2. Let's try another one. Let's try 2 plus -3. Okay, make a number line. Something like 0, 1, 2, 3. And my negative numbers, -1, -2, -3, -4, -5. So I'm starting out at 2, but I'm adding a -3. And we said when we have negative, we always go left. So I'll go left. 1, 2, 3. And where do I end up? I end up at -1. Let's try another one. Let's see, how about 3 plus negative 6? Get our number line. 0, 1, 2, 3. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. Okay, we're starting out with our 3. Now the negative sign means we go left 6 units. 1, 2, 3, 4, 5, 6. And where did we end up? We ended up at negative 3. So when we look at this problem here, and we look at this problem here, can we derive some kind of a rule from that? So we said that 2, I'm going to rewrite them, plus a negative 3 equals a negative 1. We also said that 3 plus a negative 6 equals negative 3. And I'm hoping by looking at these, you can kind of see a rule. And the rule is when we add, see here, we were adding integers with the same sign. Here, our integers have a different sign. So here we have a positive and a negative. Here, there is a positive in front of the 3 and negative in front of the 6. So these integers have different signs. If we ignored the signs and thought of these numbers in terms of absolute value, we thought of this as the absolute value of 2, and we thought of this as the absolute value of negative 3. Well, we know that the absolute value of 2 is 2. The absolute value of 3 is 3. If we thought of them that way, is there something that we could do to help us derive a rule to add integers with different signs? And what I see when I look at it is that if we take the absolute value of each number, we take the absolute value of negative 3, which is 3. So we're going to think of it in terms of absolute value. And we take the absolute value of 2, which is 2. So we basically are essentially ignoring the signs. And we just subtracted them. We would get a 1. And if we said as part of our rule, we have to take the sign of the larger absolute value, which is, in this case, the larger number is the 3, and it has a negative sign, and we put that with the answer. Could that be our rule? So could we say, ignore the signs when you add integers with different signs, ignore the signs, subtract, so that would be 6, minus 3 equals 3, and take the sign of the larger number, which is the 6, so that would be negative 3. So let's write the rule. To add integers with different signs, ignore the signs, subtract, and then take the sign of the larger number. And those are basically your rules for adding integers. So let's get a new page here. Uh, let's see if we can just add a page. Oh, right. I will just page. Okay, here we are. So now let's subtract integers. We've added them. Let's subtract them. So now if we have the same sign and we have different signs, what kind of rules can we derive when we do this? So let's say we have -6 minus 3. Let's say we have -6 minus -3. Okay, let's look at those two examples. Their equal sign. So we have our number line, and we'll put our 0 here. 1, 2, 3, -1, -2, -3, -4, -5, -6, -7, -8, -9. We'll go up to -10. And we definitely need to change our color. Okay, so in the first case, we'll use this color, this green. -6 minus 3. So if we're starting out at -6, we said when we subtract or take the negative of anything, we have to move to the left. So we'll move to the left 1, 2, 3, and the answer will be -9. So those had the same sign, but it looks like if we started out with our -6 and we just continued toward the left, keeping the sign, that could be the rule for integers with the same sign. So -6 minus 3, think of it as combining them. So what about this? This -6 minus a -3. This is a really special case. So here we have -6 minus and -3. Well, basically these will negate each other. It's kind of like saying, if I have something you want, let's say you want my $100 bill. So I have a $100 bill. That's my $100 bill. And you want my $100 bill. Okay, you're saying, give me the $100 bill. And I say to you, I cannot give you the $100 bill. Okay? That's like subtracting, or that's like a negative. But what if I said, if you begged? You begged and you begged and you begged, please, 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 please. And I couldn't resist. You gave me puppy dog eyes. You gave me flowers. You got down on your hands and knees. And finally, I cannot not, okay? I cannot not give you the $100 bill. If I cannot not, I've negated my not. And now I have to give you the $100 bill. And that makes you happy. Think of this subtracting a negative as adding a positive because it negates it. It makes it null and void. So now when we start out with the -6, I cannot not do it. I'm unable to go left. I have to go to the right 1, 2, 3 spaces. And that brings me to -3. So if I have 6 minus 3, I just continue left because I'm still subtracting. Subtract left, add right. Subtract left, add right. So here's the rule that we can come up with for subtraction. We're going to take the first number and we're not going to do anything with it. We're going to keep the first number. We're going to change the sign in the middle, no matter what. It doesn't matter what it doesn't matter what the second number is. We're going to change the sign in the middle to addition. Okay? It'll work here. You'll see. And then whatever the sign is on the second number, so right here I have an invisible positive, change that sign. So we already changed this one. Now we're going to change this one. So it's really, in the case of the first one, it's -6 plus a -1, 2, 3. So here we change the operation to addition. Next, we are going to change the sign on the second number. To its opposite. So if we have 3 minus 2, that's the same thing as 3 plus a -2. So we would have 3 minus 2. Oops, sorry, I should have done that. I did the wrong side of the number line. I can fix that. So I'll make a new number line down here. 0, 1, 2, 3, 4. So if I have 3 minus 2, gives me 1. But if I have 3 plus a negative, I'm still going to the left. And that's going to give me 1. So when we subtract integers, we keep the first number, change the operation to addition, then change the sign on the second number to its opposite. What do you do after that? You just follow the addition rules. And that's really all I wanted to say. We can make another video for multiplication and division, but that is much, much easier. Keep practicing and you'll be great.